Hi, if you are in this page, you must be interested about this course, Applied Numerical Methods. This course is primarily intended for senior undergraduate, that means third year, fourth year undergraduate students as well as postgraduate students in engineering. This course is not designed for students of mathematics or computer science. My name is Malay Das. I am a faculty member at the Department of Mechanical Engineering, Indian Institute of Technology, Kanpur. In this course, we will solve problems of linear algebra, calculus, and optimization using numerical methods. This phrase numerical methods means that we will use repetitive, simple arithmetic calculations which are suitable for non-experts in mathematics to solve problems of linear algebra, calculus, and optimization. To provide an appropriate solution methodology to non-experts, we have to create a list of this arithmetic calculation procedure, and such a list we call algorithm. Once we create the algorithm, the best way to have an error-free solution is to implement this algorithm in a computer, writing a computer program. So in this course, we expect that a student will understand the theory of numerical methods, then how to program the numerical methods in a computer, and finally to use this theory and the program for practical problem solving. In the theory part, we will discuss the algorithms and we will also identify the limits of each of this algorithm. Then in the programming part, we will write this algorithm in the form of a computer program, and we will write this program from scratch. That means without using any black box type library. Finally, many different algorithms and many different programs will combine together for practical problem solving. Of course, achieving all these goals requires certain prerequisites. We have to start from somewhere. So to begin with, we need some knowledge of programming, and we are also expecting that the students who will enroll in this course will have some preliminary knowledge of engineering mathematics. In the programming part, we hope that the student will have some preliminary knowledge of arrays, loops, and functions in any language of their choice. In the mathematics part, we expect that students will have preliminary idea of linear algebra as well as differential equations at the level of a second year engineering student. Now, for the programming, we will not recommend any specific textbook. We will discuss it in lectures, and then there are many sources that I'll refer time to time that students can take help from there. For the mathematics part, we can use any standard engineering mathematics book. Time to time we have to refer to this book to brush up our knowledge of mathematics. And the main textbook in this course will follow this Chapra and Canale numerical methods for engineers. There are currently, I believe, the 10th edition is in progress, but any older edition will be all right, because the fundamental numerical methods that we will discuss, that is contained in almost all the editions. And again, because we are putting certain emphasis on writing the programs, we need some software which will be compiler and interpreter on the language that you will be programming. And also once in a while we will visualize the result by plotting it. That is why we need some plot software. It may be open source such as GNU Plot, or it may be a proprietary software such as TechPlot. For running the programs, we need a standard desktop or laptop. This course cannot be completed simply in a mobile phone. In this course, as I have already mentioned, we will have some discussion on linear algebra, something from calculus, something from optimization, and then at the end of the course, we will discuss a little bit of advanced topics. In the linear algebra, we will primarily focus on linear solvers. That means we'll solve Ax equals b problems, that is the solution of simultaneous linear equations. We'll see that the technique can be extended for nonlinear equations as well. After that, we will talk about the eigenvalue solver. That means Ax equals lambda x type problem we'll solve numerically. In the calculus part, we'll start with interpolation, and we'll see that this interpolation is connected to numerical differentiation as well as integration. Once we learn the interpolation, differentiation and integration, we'll use this idea in solving differential equations. Once we cover the basics of linear algebra and calculus, we'll get into the optimization techniques, and we'll primarily discuss regression here and the gradient descent. Both these techniques are now becoming very important in the context of machine learning applications. Once we cover all the above, at the end of the course, we will discuss a little bit of advanced topics where we will talk about advanced linear solvers. In the linear algebra part, we will talk about very basic solvers, but in modern days, there are many advanced solvers. We'll talk a little bit about it. And then the matrix decomposition, which is at slightly higher level linear algebra we study, they become very important in these days. So we'll discuss a little bit about matrix decomposition. In all the above topics, we'll talk about theory and we'll talk about problem solving. Between theory and problem solving, we have to write the programs to solve practical problems. This gives you the overall map of the course. I understand that you may have several other questions. So the best way to get your answers is to send me a mail at this address mkdas@iitk.ac.in. So that's all for now. Thank you, and I'll see you in first lecture.